A queue is a first in first out linear data structure. A queue is a first in first out linear data structure. A queue is a first in first out linear data structure. A queue is a first in first out linear data structure in which insertions takes place one end. A queue is a first in first out linear data structure in which insertions takes place one end. Insertions takes place at one end called the rarer, and the deletions takes place at one end called the front, and the deletions takes place at one end called the front, and the deletions takes place at one end called the front. Now if you take down this diagram, it's a queue data structure. Again here I am representing queue using an array. These are the indexes. These are the data elements 10, 20, 30, 40 and 50. So let it be, this end is rarer end from which the insertion operation is performed. And this is another side end through which this is called a front end through which the deletion operation is performed, deletion. So the data is organized inside the queue based upon the principle first in, first out. So an operating system uses a queue data structure in the implementation of so many CPU scheduling algorithms. One of the algorithm is round robin scheduling algorithm. In the implementation of that algorithm, this queue data structure is required. Next, coming to the non-linear data structures. Side heading, non-linear data structures. Non-linear data structures. The following are the some of the non-linear data structures. 1. Trees. The following are the some of the non-linear data structures. Some of the non-linear data structures. 1. Trees. Take the point. Trees are used to represent just a brief explanation here I am giving. Shortly we will say about all these data structures in more detail. Trees are used to represent data that has some hierarchical relationship that has some hierarchical relationship among the data elements. Hierarchical relationship among the data elements. Among the data elements. There are different kinds of trees. General trees, binary search trees, AVL trees, B trees. So in all operating systems, the file system is maintained in the format of a tree like this. In all operating system, even in Windows, Linux, Unix, the file system is maintained in hierarchical structure with the help of a tree data structure. Next, graph. A graph data structure. Graph is used to represent data. Graph is used to represent data that has a relationship between pair of elements, that has a relationship between pair of elements, not necessarily hierarchical in nature. Not necessarily hierarchical in nature. Not necessarily hierarchical in nature. So the simple definition of a graph is a collection of nodes and edges. A graph is a collection of nodes and edges. So these are the nodes. So the circles represents nodes, the lines represents edges. So graphs are highly useful in finding shortest paths, right? There are some algorithms and graphs which are useful to find out shortest paths, and as well as to find optimum solution for some of the algorithms. These graphs are highly useful. Right, the last point, operations on data structures. Operations on data structures. Side heading, operations on data structures. The different operations that can be performed, on the various data structures are. The different operations that can be performed on the various data structures are. The different operations that can be performed on the various data structures are: 1. Traversing. On the various data structures are: number 1, traversing means display. Searching. Number 2, searching. Number 3, inserting. Number 4, deleting. Number 5, sorting. Number 6, merging. Inserting, deleting, sorting, merging. Deleting, sorting and merging.